Today we're going to look at section 5.8, applications of trig functions. We're going to continue to solve right triangles as well as do more problems involving bearings. So we started getting familiar with how do you create a bearing based off of a picture. Now we're going to start applying these bearings in word problems. So now that we understand how these work, we're going to start making them a part of these trig application problems. The process to solve these are the same as any other application problem. We want to draw a picture to help illustrate the situation and set up a trig equation to find what is being asked. So let's dive into some examples. Here it says, a boat leaves the entrance to a harbor and travels 40 miles on a bearing of south 64 degrees east. How many miles south and how many miles east from the harbor has the boat traveled? Okay, so sketching a picture is how we want to get started here. So if we think about our compass and we're thinking about southeast, that means we want to really be focusing on that fourth quadrant. Okay, so here at the origin, that's where the harbor is. So the boat leaves the entrance to the harbor and it travels 40 miles on a bearing that is south 64 degrees east. So remember, that 64 degrees is always going to be located with that north-south line. So 64 is over here. I want us to now think about how we can create a right triangle. So with the angle being there, I would kind of want to make a triangle with that angle. So normally I always have us draw a perpendicular line up to the x-axis. You can totally do that. You would then just need to find the complement and use that angle. Or in this case, we can go over here, make that perpendicular with that y-axis, because notice that the directions, or the question is, how many miles south? So I'm going to call that x, and how many miles east? I'm going to call that y from the harbor. So essentially, we have to find the two legs of this right triangle. And we know that the hypotenuse is the distance that the boat traveled, and it told us that it was 40 miles. So technically then the boat is right here at that point. Okay, so now that we have this sketch, we have two different trig functions that we're going to set up. So once again, we want to think about SOHCAHTOA. Let's maybe solve for x first. So notice that based off of my angle, we know that x is adjacent. We know that y is opposite. We know that 40 is across the right angle, so that's the hypotenuse. So if I want to find x, we have adjacent and hypotenuse, so that means I want cosine. So the cosine of 64 degrees equals then x over 40. We'll multiply both sides by 40. It says how many miles east. It doesn't give us a particular number to round to. So let's plug this into the calculator, see what we get. 40 times the cosine of 64. Let's just round it to the nearest tenth. So 1 decimal place. Notice that means that our value for x is going to be 17.5, and we're talking miles. Okay, I'm going to answer the final question in a second. So let's find what the other value is as well, and then I'll make sure that I am correctly stating which direction represent what length. Okay, so then in the next one, we want to find y. That's opposite. We're given the hypotenuse. Remember, I don't want to use that value of x because that's a rounded value. So I want to stick with the clear-cut numbers that were given. So opposite and hypotenuse, we want to use sine. So the sine of 64 degrees is going to equal y over 40. We'll multiply both sides by 40. Let's go ahead and then multiply this in the calculator. And so then notice that, oops, didn't do that correctly. In the calculator, if we want to also round to the nearest tenth, notice that we get 35.95. The 5 rounds the 9. So that essentially then moves the 35 up to 36. And that's once again miles. So if it says how many miles south and how many miles east from the harbor has that boat traveled, we can say 17.5 miles, and that's the X, which is representing south, and 36 miles east. And there is my final answer. Let's do another example. It says a ship sights a lighthouse directly south. A second ship, 9 miles east of the first ship, also sights the lighthouse. The bearing from the second ship to the lighthouse is south 34 degrees west. How far to the nearest tenth of a mile is the first ship from the lighthouse? Okay, lots of information here. So a ship sights a lighthouse directly south. So that means that, let's say this point right here is my lighthouse. It needs to be south of these boats. So directly south means that I'm going to have, well, let's make that nice vertical line from that lighthouse. It's not the straightest line, but this point right here, we can say that this is ship number 1. Okay, because it's directly south of that lighthouse, or the lighthouse is directly south. So then a second ship that is 9 miles east of the first one. So east is to the right. So right here is ship number 2. It is, once again, 9 miles. It says that it also sights the lighthouse. So that means that it sees the lighthouse. So technically then we have this right triangle. It says the bearing from the second ship to the lighthouse is south 64 degrees west. So that means the second ship, I'm going to kind of think of that as where the origin is. And if I want south 64 degrees west, that means that this angle right here is that 34-degree angles, because remember that acute angle is always going to be formed with that north-south line. So now it says to the nearest tenth of a mile is how far is the first ship from the lighthouse. So I don't know that distance. So notice that because I've just created this quadrant here, I basically created a picture in the third quadrant. That 34-degree angle is outside of my right triangle. So I need the angle that is complementary to it. So to find this angle right here, we're doing 90 minus 34. And so that's giving us a 56-degree angle. Based off of now our picture and looking at SOHCAHTOA, I see that based off of the angle, we are dealing with wanting to find the opposite side and we are given the adjacent side. So we're thinking tangent. So the tangent of 56 degrees is going to equal x over 9. We'll multiply both sides by 9. And once again, it says to the nearest tenth of a mile. So to 1 decimal place, we are going to get that rounded to 13.3 miles. And there is the distance from the first ship to the lighthouse. Let's do one more. It says a ship is 9 miles east and 6 miles south of the harbor. What bearing should be taken to sail directly to the harbor? Okay, so if a ship is east and south of the harbor, that means that the harbor is somewhere up here. Okay, so ship is 9 miles east. So I need to go 9 miles to the right and then 6 miles south. This is where my ship is. So notice that. I don't know why I made that dotted. Let's just connect that. Here we've got this right triangle. Okay, so it's asking what bearing should be taken to sail directly to the harbor. So I want to start at this ship. So I want to create that quadrant. That's where my origin is where the ship is. If I want a bearing, I always want that bearing, remember, formed with that north-south line. So that happens to be the angle that's here inside of this triangle. So if that's the angle I want, notice that we are given the opposite and the adjacent sides. So we're going to use tangent to find the measure of that angle. So the tangent of, let's call it x, I don't know what that angle is, equals 9 over 6. So because we're finding an angle, we're going to use that inverse. So second tangent, 9 divided by 6. And because we're talking about an angle, let's go ahead and let's round it to the nearest degree. So when we do that, we are going to get a 56-degree angle. So because that is then the angle that I need, because it's created with that north-south line, that's the actual measure of my bearing. So remember, directions, we're in the second quadrant, so that's north, and that's also going west. So we want north 56 degrees west. That's the bearing from the ship to the harbor. Go ahead and pause the video, see if you can do this checkpoint problem. Okay, so with this, here's my picture. A couple different ways for you to set it up depending on which side you wanted to create that triangle. But essentially, you should have gotten 77 miles north and 95 miles west. And that's us solving a right triangle, but incorporating those bearings into those application problems.